Morning, guys, and welcome back to another round of Steel Connect webinar. I'm Rocky, and your host today to talk about steel and building related topic. So today we'll be talking about on-site installations and quality control of external cladding. So how do you manage it? So you wish to have a well-constructed building. So most often when you design a building, it does not just happen on the paper. The building itself has to be built, by workers, by involvement of other parties. So it also relies heavily on good execution on site to actually realize the design. So it actually leads to good execution can actually lead to less maintenance on the long run. Meaning, if let's say you have done it right on the first time, then you would require less or no maintenance to maintain your building. So all in all, good design plus good execution would lead to an excellent outcome. And it's actually very possible to achieve such level of execution because nowadays we have technologies where it can actually help us to manage on-site works as well as real-time surveillance where you can address the issue much more immediate. So with that, let me just put a note here that this kind of good execution, it relies heavily on collective efforts, both from all the way people who are actually doing the work, all the way up to when people are doing the designing, meaning when architects are doing the designing. It should also have this in mind, where how easy it is for on-site workers to actually execute it. Right? So let's start with our topics today. Of course, upon this cladding material arriving on site, I think it's a good practice, goes without saying, that when you open package of any material or any products, then you should actually inspect the product upon arrival or upon opening, whether there's any defect. So these are some of the common things that we see on site. So cladding dents, paint crackings, or even sometimes scratches. So these are the things that you ought to look out for when you open the package. So if there's any issue with, that you spotted, then my recommendation is that you should not, ignore it, because at the end, if let's say you just install it by ignoring all these small problems and your client or owner do not accept that, then you will spend more effort or more time to actually replace it or take it down. So it requires more resources to fix it. So it's best to actually be transparent and be clear upfront and tell the supplier, oh, there could be an issue with the material, and so on. Of course, upon the material arrival, of course, if let's say the site itself, like nowadays, you have a lot of delays because of restrictions like movement control order, then you might want to consider a proper storage for all this building material. And one thing that for cladding to know is that, or for most of the material, is that the condition itself should not be shown. Be places where you have the area will be prone to flooding. So if the storage area is prone to flooding, then you will have what we call wet storage condition. And wet storage condition normally would affect the material quality. And how it affects cladding is that because cladding itself arrives is in stack. So if let's say the water is flooded over the stack of cladding, then it will actually penetrate or trap in between the cladding stacks, and this is what we call a capillary effect, where water will be seep through the cladding stacks and be retained in between it, and over a prolonged period of time, those moisture could actually affect the bare finish coating performance, as can be seen in this picture. And of course, for painted product, it most often would actually soften the paint layers, and sometimes even cause light stains on the paint finishes. So all these are most likely seen if, let's say, you have stack of cladding that was stored on site, then you observe there are like tons of water trapped in between. Then this kind of sign is very common. So, and another thing is that if, let's say, you want to work with all this material after unpacking it, and then you found all this water, then what you should do is you should actually dry it before you even do any installation. The reason why is because, like I mentioned earlier, the paint can get softened very easily if it gets softened because of the wet condition. So if, let's say, you straight away work with it, then there's a chance where scratches can be formed very easily. Okay, so that's why in order for you to work with it, you have to dry it first, and that presents additional resources, additional time for you to do that. That's why the best way is actually to provide a proper storage area where it is away from all these wet storage condition. And one of the common ways to do it is actually raise up the whole stack of cladding. And of course, how high it should be, right? It depends on the site. So if, let's say, your site is prone to flooding of maybe just a small 1 cm height, then maybe you should prop it higher than that. Of course, if, let's say, the site is prone to flooding of over one half a meter, then maybe you ought to look for some other platforms to do the storage. So typically, this is the recommendation. First, you should prop up the whole stack of cladding, and second, you should actually tilt it in a slope condition, like shown in this picture. So this, even though there could be any types of capillary effect where water could seep in, by presenting a slope, the water will be able to flow to the lower end and then drip out from the other side. So it allows water flow, right? And another thing is that you should also cover it with some kind of tarp or even canvas to prevent any type of direct exposure to rainwater. So all these have one intention in mind, which is to prevent any types of wet storage. So of course, at the end, when it comes to these design stage at the beginning, I think designers ought to look for how to actually manage all these material storage also, not just designing the whole building, but also designing the site during the construction stage. And I think with today's technology, we are able to do that very easily. So on to the next point of on-site quality control and installation. One of the things that we observe is cutting on site. So cutting on site can actually present some problems. All right, sometimes if, let's say, you neglect this step, then you will observe what we call burr edges. So burr edges typically happen on metals that are cut using grinders, right? So, or abrasive cutting. And as you can see from this picture, burr edges will actually present rusts where the cut edges is not clean, it's not a clean cut, and the rust will start from these edges, and it would slowly propagate inward. So it's very crucial for you to get this cutting right, if, let's say, cutting on site is absolutely necessary. So based on my study, I actually summarized the cutting type into two motion. Today, it might be a good opportunity for you to explore what are the options or what are the tools to use for on-site cutting. And for those who are not involved but then have a power to recommend, then perhaps you can take note of this. So like I mentioned earlier, based on my study, I summarize it into two types of cutting motion. So the first one is what I call circular cutting motion. So circular cutting motion is typically more abrasive. And second one is what we call shear motion. So shear motion, as you can see from this diagram, will be much more cleaner in terms of cutting method. So I'll be running through these 5 types of cutting tools and how each of them differ from each other. So let's get into the circular motion cutting first. So the first type of cutting method is called or cutting tool is called an angle grinder. So it employs what I call circular motion cutting. And this type of cutting tool is very common nowadays. Even household toolbox, you will have this grinder. And most often you would imagine it when you do the cutting, it would generate what we call sparks, right? And this is how we call it, how we notice it's actually a abrasive cutting method. And typically, if you use grinder to cut sheet metal or steel sheets, then you will actually generate what we call burr cut edges. And these burr cut edges could actually, have the rusting that I've shown earlier and some of the examples here. And let me just explain how these burr edges is generated. So you have the grinder disc, okay, cutting ideally is perpendicular to the steel sheets, but most often it's not the case. You will tend to form certain angle because there's fast motion of circular motion. So you tend to vibrate a bit, and when you do the cutting, they could form a certain angle, and the cutting could not be done in a clean method. So at the end, what you will have or what you form at the cutting edge is what we call malleable steel edges, where all these steel are meant to be removed but not completely removed. And the extension of all these steel sheets are what we call burr edges. Okay, burr edges are not intended to be there for a clean cut method. So what you will have in the end is that all these steel edges does not have any type of coating remaining on the surface, so it will start showing sign of rust, as shown on this picture. And most commonly on site, you see this done on trusses, steel trusses members. Normally they use grinder. That is the most common way that they will answer you all. They use grinder to cut the steel members, right? So perhaps you should explore another type of cutting tool instead of grinder. So another type of circular motion cutting is what we call cold cut saw. So cold cut saw has a same cutting motion, which is circular motion. But what differs cold cut saw from the angle grinder is that they use a different kind of cutting blade. And when you do cutting, as the name suggests, you will not see the red hot sparks being generated. So that differs from the grinder. And typically for cold cut saw, it would provide a straighter cut and relatively cleaner cut edges. But there's a caveat. You will need to look at what type of cutting blades to use for the cold cut saw. And based on my study, these are the two common ones, but you should look for the sign that says the blade are meant for mild steel. Okay, as shown here. This example shown here is a cement tip blade, and it's stated clearly for mild steel. Okay, and another type which is more common or seems to be perceived as more tough and superior is called carbide tip blade, and is stated there for ferrous metal. Ferrous means for steel. So these two types of blade are, is recommended, to use to cut steel sheets. And this is one of the trials that I've done, during my study to try and cut it using this cold cut saw. And what I noticed is that the cold cut saw, it requires a certain level of workmanship skillfulness. Because if let's say you are not skillful, like I was not skillful, you could actually create certain burr edges as well. So there you would need to consider, the skillfulness, whether the workers who are using it, whether they are skillful or not. If let's say they are skillful, I think the likely chance of you getting a clean cut is high. But if let's say you are unskillful, the workers are unskillful like me, then you could have this kind of photo, where there's a small sign of burr edges. But again, it's still better than the angle grinder. So So moving on to the second types of cutting motion, which is on the shear cutting motion, we have the first type of cutting tool that uses this kind of cutting motion is called thin snips. So thin snips is basically a tougher version of scissors, right? And typically they function the same, where uh, basically you have the shearing motion to cut the sheet, be it paper for scissors and metal or steel sheets for the thin snips. So over here, thin snips it can be classified into two types of thin snips or shear. One is called single cut shear. So single cut shear works very similar to scissors, where it basically shear the sheets away and does not generate any types of byproduct. You don't see any types of sheets coming off the component. Another type is called double cut shear, where if you do the cutting right, then there will be thin strips of byproduct, also called offcuts, from cutting it. So these are the two types of shear that are very common. And by employing this shear cutting or thin snips, actually the cut edges are almost guaranteed to have a clean cut, right? So the cut edges will not have any concern of any premature rusting. And another type of shear motion cutting is called nibblers. This is perhaps lesser known equipment, but these nibblers, again, putting it in a much more day-to-day equipment, is the paper puncher. So for those who are unfamiliar with this paper puncher, you might be over the 2000s era. So paper puncher and this nibbler works in the same principle, where this is how the nibblers works, where it will just just munch away a bit by bit of the material. And the result of this nibbler's cutting edge would be a serrated cut edge, meaning there will be a certain sort of teeth kind of finishes. But this kind of cut edge is still considered a clean cut edge, and it would not create what I call burrs. And over the long term, this is a clean, safer cutting edge compared to others. So to summarize this second point on cutting on site, like I presented, there are a few cutting tools presented, and out of these cutting tools, angle grinder is not very suitable for cutting sheet metals, based on the reason that it actually creates burr edges on the sheet metals, and this actually would jeopardize the cut edges performance or protection. And on the cold cut saw, yes, it could be a better option compared to the angle grinder, but it depends on the skillfulness as well as that you use. That's why I put maybe for suitability. And as for the shear cutting method like thin snips, both a single cut shear as well as double cut shear, our answer is yes. We recommend it, and it's very suitable to cut sheet metals. And the last one will be on nibblers, which as you can see, it provides a cleaner cut as well. So that is our take on cutting tools and that you use on site. Of course, coming back to the designing and planning stage, if let's say you know that your roofing length is so and so, there's always an option of discussing it with the roof formers or even the installers, how to actually manage this. You can actually design it with single length, like what you see here, row on site, or cut it to certain geometry or certain length. So that are all done on the planning stage or even designing stage, where you can have the freedom of determining it beforehand, so you can minimize the cutting on site. So those are the certain uncertainties that you want to prevent. Anyway, leading to the next point, it actually has a heavy influence on what type of cutting tools that you use, and leading to the next point. Okay. So different kind of cutting tools. Just now I mentioned a few. like the single shear cut, those doesn't generate any cut of cuts, all right, or byproducts. But like double shear cuts, it normally would generate what we call streak cut of cuts. Okay, as you can see from this picture. Nibblers would typically generate steel swaths, and for angle grinders, it would normally generate fine steel swath, meaning fine steel powders, as you can see from this picture. So, leading to the next point is on swath removal. So swath, as you can see, is the dotted spots on this picture. So it's basically a rust spot. Okay. So I'll explain what is swath and how to actually remove it. So in my previous episode, we talked about rust stain on say other rusted components like flashings or mouth steel racks and so on, and all this how this rust will actually spread onto an adjacent surface, like shown in this picture. And we can have a lot of examples here. This is one of the site case studies, and you can see the brackets that are rusted actually the stains itself actually spread onto the adjacent surface. Okay, and it doesn't just occur on the spreading doesn't just occur on adjacent steel component. It can happen on say other non-ferrous or non-metal components as well, like this translucent sheet, right? So rusted parts. Okay, so one of the possibility or common way that it happens is that it links back to the cutting method. I mentioned earlier, different cutting method generates a different kind of cuts. But the most invisible one would occur if, let's say, you use an angle grinder, where normally if you use angle grinder, the hot swath particles, basically the sparks generated, it will fall onto adjacent surface, like what is illustrated here, and the hot swath would immediately adhere onto the surface because it's hot at first, and the surface could be conducive for adhesion, right? Because it could be painted and so on. So the surfaces would readily accommodate all these swath particles, and sometimes or most of the times it's hard for you to actually get rid of it by just exposing it to rain, right? That assumption is totally not consistent with what we saw on site, right? So all these swath particles might not be detected in the early stage because it has not rusted at first, but it will come back and haunt you because maybe in the span of a few months during your construction, you will see these rust spots coming to life, basically appear out of nowhere, and all these swath particles actually will start rusting. The reason why it starts rusting is because uh, during the cutting motion of abrasive cutting, the soft particle, typically steel, it would lose its protective coating. So what happens is that it will actually start rusting outside of the material, and all these soft particles are commonly perceived to be a problem or a quality issue of the steel sheets or coated steel, which is not the case at all, where the particles, as I explained here, is that the offcuts will actually fall onto the external surface, and without any protection, it will start rusting. That's why you see all what we call swath stains or swath particles. And it does not just appear on the external, it will actually affect the coating itself as well. As I covered in my previous episode, how it affects is that the galvanic coating or the aluminum zinc coating, it now has to protect not just the steel beneath it or the steel that it is covering, but also the steel that is introduced on the external surface. So it has to work faster and harder to protect both sides, even though the external steel are already rusted. So this presented a risk of accelerated corrosion on the specific areas where it's in contact. So this is a very specific examples where you can see all the swath or so-called steel offcuts, start causing the steel cladding to rust. So there's actually ways to remove it. Of course, the easiest, if let's say you notice it, or you realize there's actually soft particles on the first day, then you should remove it by first wiping it using cloth, or even sweeping it away using broomstick. Okay, that is the most common or most easiest way. Because if let's say you don't do that on the early stage, it will actually be harder for you to remove it. So this is just a short example of me trying to remove the swath using my fingernails, and it doesn't work for most of the case when it's beyond say 2 or 3 months, because the swath particles would have already adhered onto the surface. But there's still possibility of you removing the swath, okay, by using this washing method. Okay, so this we have done a lot of recommendation on this, but just for this chance, we would like to just re-highlight again. So what you need, there are two tools that you need. First is the scrub sponge. Okay, scrub sponge means you go to any household aisle of the supermarket, you will see sponge, right? So the tougher part of the sponge, the green color part, is what we call scrub sponge. And another tool or ingredient that you will need is mild household detergent. Any types of dishwashing detergent that you have at home would be able to do the job. So we just mix it with water, make it mild. So this study itself, we actually conduct a lot of studies on site. So this is one of the swaths that we observed on one of the buildings after it's been completed for more than 10 years. And you can see there's a minor swaths on the surface. And after using the scrub sponge and and the detergent, not detergent, and we scrub the swath surface and hence removing the swath. But this is not true for all cases, yeah, because most of the cases will be swath, like I mentioned earlier, damaging the coating and then penetrating through the coating. Okay, like this example on the same building. Okay, you can see minor swath. It does not look severe, but upon attempting to actually wash it, okay, we can remove part of the swath particles. But because there was a lot of swath particles in one spot, the coating itself won much faster. So after attempting to wash it, you can still see signs of rust. That means at this area, the swath has already penetrated through the coating. Okay, so it might have been too late already for this area. But anyway, so there are also other types of washing or cleaning ingredients or tools that is quite out there, but we do not recommend this kind of abrasive cleaning methods. So what I classify as abrasive is solvent or ingredients that involve solvent, such as say kerosene or thinner or sometimes petroleum, right? All these solvent-based cleaning would actually, if let's say it's a painted product, it will actually remove the paint layer or remove part of it. As for the tool, earlier I recommended scrub sponge, but if let's say people perceive like the steel wool will be better, no, steel wool will actually damage the surface further, such as causing more scratches. Okay, so which leads to the next point of scratch prevention. Okay, so this next point on scratches is also one of the things that we see common. Okay, and people will panic over minor scratches and so on. So today is a good chance for us to cover this topic. So scratch itself can be formed in many mechanical damages or ways to damage the surface. But one of the things that we note or realize is that most often when workers work on site, they would wear safety boots. Okay, and all these safety boots normally have deep grooves, right, where it would actually trap pebbles in between the grooves, and they would carry all these pebbles and wear the safety shoes onto the roof. And while walking on the roof, they will actually cause scratches. So alternatively, what we observe or recommend is that instead of using just normal safety boots, when you walk on the roof, perhaps you can consider using flat rubber shoes. Okay, so flat rubber shoes would have a flatter sole, where it is less likely for the grooves, because it's flat, to carry pebbles and all the way to the roof. So the intention of changing the attire or the shoe is to actually to prevent any types of scratches on the metal roof. Of course, it's a bit counterintuitive considering that for the workers, they are considered to need to have a certain safety level. But think about this: if let's say you're working on roof, how often do you carry heavy objects, right? So actually, safety boots might not be the best shoe for you to wear on roof. At the same time, it would be more cumbersome. Those people who have worn safety shoes and walk on the roof, you would understand what I mean, right? It's much more cumbersome for you to walk on the roof. Whereas if let's say you use rubber shoes, then it will be much more easier. Okay. So another thing that could potentially scratch or cause deep scratches on the coated steel or cladding is dragging of items or heavy items on the roof, right? So this kind of dragging normally would create damages that are penetrating through the coating and cause what we call severe scratches. Of course, all these type of different mechanical scratches, we can actually classify into different severity in terms of scratches. So in this scratch session, we would like to note that if you see any types of scratches, please don't panic, because we know that a lot of people will panic over minor scratches. Okay, so based on our experience, there are different types of scratches, and we can quantify into different types of scratch width. And based on our experience, the rule of thumb is that if let's say you see the scratch that are more than 2 mm in width, then normally you will see sign of rust immediately, right, within the span of 2 to 3 weeks after the scratch has been caused, right, by any reason. So the scratch width, when we say more than 2 mm, it means scratch all the way to the steel base. If let's say the scratching hasn't reached the steel base, there's a chance for the coating or the area that scratched to still be performing or to preventing the rust, right? So here I show you an example of a scratch that has not reached the base steel yet. So over the span of at least 10 years, you don't see any sign of rust on the surface. So perhaps these are what we call minor scratches. Whereas for this kind of scratch where it is definitely more than 2 mm in width, you can already see sign of rust on the surface itself. So this kind of scratch is considered what we call severe scratches, and you should consider doing something to it, or perhaps if let's say it's still early on, you can actually replace it. Okay. So scratch that are minor, like shown earlier or in this picture, should be left untouched, meaning you should not do anything to it. Okay. Because the coating that is still left on the surface will able to prevent it from rusting. Okay. So here is another study where we observe some of the scratches that are light, and over this cladding itself has aged over 25 years, and you don't see any sign of rust on the surface, even though it has those kind of minor scratches. Okay. And one thing to note is that those minor scratches from far, you don't see any, it's very hard for you to trace where are the scratches, because from far you don't really notice it, right? So why we actually highlight this is because most often when people saw scratches, they would be panicking, and then they will start asking for the similar color kind of paint, and then they start considering touch-up paints. Okay, so when scratch happens, severe scratch especially, there are actually two options, where first you can actually replace it, or second you can actually use touch-up paint. Of course, the latter of touch-up paint is not what we recommend, because if you do touch-up paint on a small area, especially the minor scratches, then there's a guaranteed chance that you will actually see the touch-up paint in terms of color difference very easily. So it's much more visible from a distance away. Okay, so all in all, if let's say you apply touch-up paint, what we can see is that you will guarantee to have a color difference on the cladding surface compared to say minor scratches like this roof itself. You can almost guarantee that there are color difference. The reason why this occurs is because there are tons of factors. First is because the paint formula is different. The paint curing methods is different with what we do in our factory, and also the thicknesses of the paint is also different, right? The one you paint on the roof or on site is typically uneven and much more thicker. Okay. Not just that, touch-up paint or overpainting normally would present other challenges such as whether the paint are suitable to be used on external, whether the surface preparation is done right, and so on, and how long it will last, and what is the color, stableness of that color that you paint over. So a lot of factors. That's why at the end, our decision or our recommendation is, please, if let's say you see any type of scratches, please don't panic and consider the severity of the scratch before you do anything, before you decide any types of remedy action. Okay. And that summarizes our fourth point, and moving on to our last point of following traits. So following traits, what we mean by this is that the cladding itself first was done by, say, installer or roofer, right? It could be done in a proper manner, follow the proper guideline, and executed well. Executed well. But most often, ideal case is that there could be other parties that comes in to do other types of installation or other types of trade works. That's why we call it following trades, meaning other works that are done subsequent to your installation. So those types of trades could jeopardize the quality of your cladding. Okay. So that's why it's very important for each party to actually take note by taking photos for record purposes of the job that you have done. Okay. So the reason why is because there's often negligence of following trades, meaning like this photo shown here. The roof might have already been done excellently, proper execution, but somehow there are other trade workers come in and do not understand your industry, and they just do their work and quite selfishly they've done their work right, but then the surrounding are damaged by their messy work like this one, where the cement powder are all over the roof, so they have to wash it. So for this specific example, is what we call mortar stains or cement stains. The cement stain itself is basically sometimes when they do patch up work, the cement could accidentally be spilled onto the roof, and workers could assume that you can actually remove it easily after it's dried off, right? But that's not always the case, or most often it's not the case. The mortar or cement stains normally form strong bond with the surface once it's cured. Okay, and so that's why it's hard for you to actually remove it once it's cured. So this is one example that we have encountered in recent years, where you can see before the mortar stains or plasters is removed, it was all over the surface, and in this case the contractor attempted to remove the cement or mortar stains, and during their removal stage they actually found it hard to remove, and at the same time it's impossible for you to remove the mortar stains without damaging the coating. So at the end you can see all these close-ups, you can see scuffing, you can see scratches on the surface. For us, this is not a way to actually address the mortar stains. Of course, if let's say your client has no requirement on the finishes, you can actually try to do this. Again, our opinion is always customer centric, always client centric. So if your client can accept this, then we are fine with it. Otherwise, I think client will have a lot of comments on why the cladding is appearing so. Right? So another thing to note is that the following traits is the foot traffic. So nowadays we observe there are a lot of additional values added onto the metal cladding, such as say solar panel systems and whatnot, right? So there could be frequent foot traffic on the metal cladding, especially the roof. So sometimes certain workers could be jumping or maybe hopping around the metal roof because they want to get to another end of the roof faster. So in doing so, they could easily dent the metal cladding. So this is something that could actually jeopardize the integrity or so-called the longevity of the cladding, because once there's any dent that is severe enough to actually cause the water to have ponding, then what you have is what we call water ponding issue, where the areas where there's prolonged contact of water will actually accelerate in terms of weathering. So this topic has been covered in the previous session. So if you want to know more about this topic, you can always go to our website for the content. Anyway, so coming back to this denting and also foot traffic. So what we recommend for designers is that if let's say there's a foreseeable amount of foot traffic on the cladding, then perhaps you might want to consider designing the cladding with a certain dedicated walking platform, as shown in this picture. So those are the things that perhaps you as a designer will want to consider cost in or to factor in when you're designing the roof as well. So yeah, so that summarized the last point of following traits, where I covered mortar stains as well as the foot traffic. So those are the things that all parties should take note of. Okay, so to summarize today's session, I covered actually 5 points. So the first point is I mean, all these are actually related to on-site installation and quality control. Okay, so the first point was storage on-site and handling. So like I mentioned earlier, upon arrival of the cladding, you might want to actually inspect properly whether there was any damages done during the transportation or during the manufacturing stage. So that gives you an opportunity to actually discuss or minimize the work needed to actually salvage or fix the problem if let's say it was already installed. Okay. So in terms of storage also, perhaps for designers, you want to look at whether there's any dedicated and suitable storage area, okay, to prevent any types of wet storage issue. On the second point, I covered cutting sheets on site. Of course, ideally, if let's say you can design the building to have a cut, have it cut to length in the factory, then that will be ideal. But otherwise, if let's say you absolutely need to cut the cladding or roofing sheets on the site, then you might want to consider more suitable cutting methods, such as the nibblers or say the pin snippers, right? And I believe all these tools are actually widely available in the market. So basically, of course, aside from that, there's swath removals. So swath removals depend heavily on what type of cutting tool you use, right? So like just now the polling questions, most of you actually answered, the most common one that you use or you've seen using is actually an angle grinder, which could generate a lot of swath particles. And the swath particles might not be visible at first, but then it will be coming back to actually show a lot of swath rust stains on the roof. And again, those are normally perceived to be a problem of the cladding, but not really. And today I covered how you should actually remove the swaths, right? And the the second last point is on the scratch prevention, where I covered, you know, what type of shoes that you should use when walking or working on the steel cladding. And uh, if let's say you see there's scratches, don't panic. Remember, don't panic. Please consider the options of leaving it there, because the if you consider the option of painting over or touching up paint, then there is a consequence to it where you have to factor in or get consent from the owner, right? Otherwise, once you have done it, then there's no going back, and maybe the client or the owner cannot accept that. Okay. And the last point on following trades relates heavily on, of course, following trades actually covers also the soft or scratches and so on, because those are the possibilities of following trades occurring, okay, on the roof. So cutting on the roof can be very possible. Walking on the roof with safety boots can be very possible as well. Okay. So other than that, of course, mortar stains and also the foot traffic that you need to consider. Okay. So during designing stage, there could be a better way to actually factor in, or maybe designing it with a dedicated walk path. So that covers the last point of following trades. So that I will move on to the next stage of question and answers. So I saw there are actually a few questions coming in. So we'll address it one by one. So the first question is, does BlueScope provide paint touch-up or warranty aside? I am of an opinion that BlueScope should provide this support to their customers. Okay, so in terms of paint touch-up, like I mentioned earlier, this is not the first option that we would recommend, or rather we would not recommend it, because at the end, what we see is that they could be inconsistent in terms of appearance of this touch-up paint over the painted finishes. So the reason why we do not recommend it is because, like I mentioned earlier, there are too many factors for us to consider, such as the type of paint, the people who actually apply it onto the surface, the thicknesses, the surface condition, the surface cleanliness, the weather, whether it was hot when you apply it, whether it was cold when you apply it. So too many factors for us to consider, and we cannot control that. That's why we do not want to endorse something that we are not sure whether it would appear as what the client would expect it to be. So that's why we could only present this option to you to consider and to consult further with the paint supplier as an option. Okay, of course, all this in mind, what I would encourage you to do instead is, if let's say the reason for you to paint over is because of scratches, then you should not think about the type of painting or whether the type of colors to use, but rather how severe is the scratch. So if let's say the scratch is not severe and it's not observable from far distance, then there's no question to start with, right, of what kind of paint to use or who to look for all this touch-up paint. So in terms of so I hope that answer your question of whether BlueScope should provide that support to their customers, because again, like I mentioned, we do not want to endorse on things that we are not able to control or not able to give you a certain very certainty. All right. So the second question is why your product can't withstand wet storage condition. Roof and wall cladding was installed to withstand weathering or rainwater. Okay, so I think when I present the wet storage condition, maybe certain audience would have a question of, okay, yeah, your cladding is meant to be exposed under the sun, under the rain especially, but why can't it withstand wet storage? Okay, so let me just explain the basic difference between wet storage and having it installed on the roof and then exposed to sun and rain. The difference is that for those normal application when it exposed to sun and rain, there's a cyclical event where the water could flow off and dry off within hours, right? But for wet storage, what you have is a prolonged contact with moisture or prolonged contact with water. So what it presents you with is all this water will start penetrating or seeping through wherever void that they can get to and start activating the galvanic reaction. So if you have seen my previous sessions, you will know that galvanic reaction relies on three conditions, actually basic three conditions. First is it should have a difference in terms of the metals, right? Be it aluminum with steel, aluminum with zinc, and so on. And the second is on whether there's any electrical contact between those two metals. And the last one is electrodes. Electrodes can be water, right? So if let's say the water is there, for a prolonged period of time, then it's very conducive or very frequent for the galvanic reaction to happen. So it accelerates the reaction. Okay. So in the long run, not long run, really short run, your wet storage corrosion would present so-called rusting or deterioration. Right? So that's why it's not recommended to have such condition be presented onto metal or steel components, right? Uh, uh, don't get me wrong, not just steel, yeah. Any types of metal would actually react in terms of galvanic reaction with the presence of water or electrodes. I mean electrolytes. Sorry, not electrodes. I need to correct my earlier comment. It's electrolytes. Okay. Okay. So on to the third question. Please, can you brief a bit on fastener hole forming? Okay, thanks. All right. So on fastener hole, I think what you are referring to is when you drill your fasteners through the hole, what will happen to the holes? I assume that's what you are asking. The concern of this fastener hole is actually quite limited to if your fastening is not done right. If let's say your fastening is secured properly, there should not be any moisture seeping through the fastener holes and causing what we call rusting. So normally fasteners, when you drill through, the edges will be what we call cut edges. So it will be covered by some kind of gasket or some kind of rubber, right, or EPDM or so on. And all these cut edges should not have any issues on premature rusting, also called cut edge rusting, if you properly fasten the screws. So unless the fasteners are loosened, then you will have issue with the water seeping through. That's the first. And second one would be if let's say your fasteners are loosened, then the shank of the fastener, which has already had all the coating removed because of its interaction with the steel sheets, then it will actually start rusting from those areas, and the rust will start spreading with the cut edges. Through the cut edges. So typically, that's what we observe on a fastened area. So I hope that answer your question on that. So moving on, how to ensure the cut edges upon cutting still can provide enough corrosion resistance. What you're asking is actually after you do the cutting, how to ensure that the cut edges, the area where you cut, can still provide corrosion resistance. Okay, simple is that first, like I mentioned in the cutting on site section, if you observe on the cut edge, right, there is any sign of burr, right, meaning those extended steel components that was meant to be removed but then was not removed completely. In the market, there are actually some tools that what we call deburring tools. Okay, DEBURR. Okay, deburr tools or deburring tools. Those tools can actually remove the burrs. Okay, so to actually prevent those cut edge rusting from happening. But of course, ideally, if let's say you can employ those cutting methods on site that does not present the burr, then that would be the simplest way to prevent cut edge corrosion from happening. Um, yeah. So I hope that answer your question in this part. So what tools do you recommend to remove soft particles, and how frequent we should perform inspection to ensure no soft particles? Um, I will classify into two stages. Soft particles removal at the early stage, meaning on a day-to-day, housekeeping method, is you should have a broomstick, you should have a cloth around. When you've done the work, end of the day, you should do housekeeping, meaning just like your house, you should do sweeping of the floor, meaning sweeping of the roof cladding, and if let's say you see any types of particles, then just remove it off the roof, but not to the gutter, yeah, because the gutter is still made of steel sometimes. So to some kind of a tray, or maybe you just use cloth to actually pick it up, right? So of course, after, okay, it's too late, when the soft particles is already appear onto the surface where it start rusting, then there's a likely chance that it will adhere onto the surface. So of course, you can still try to use cloth to actually wipe it off if you can. But if you can't, then perhaps you should consider the option that I presented earlier of using the scrub sponge. All right, some of the famous brands that I'm not gonna mention, uh, they call it Scotch-Brite or something, household brand. So scrub sponge, okay, the green color one, they are non-metals, they are non-steel sponge, and that is a tool that you use to dislodge it. Of course, one thing that I didn't mention in this session earlier is that if the product is bare finish, then the scrub sponge itself is sufficient enough for you to actually remove it, because we have seen some cases where the workers are just too hardworking, they were just too dedicated in removing the swab, where they actually overwash it in the end, causing some kind of abrasion onto the surface. So bear in mind, those two are to be used to remove the swab, yeah, swab particles, so that it prevents a further damaging of the surface. Okay, not to actually clean it to the point of it's like dishwash your dish clean. All right. So I hope that answer your question. So the next one, how to properly treat the cut edges. Okay. So common perception is that just now I asked one question is about how often do you see cut edge rusting, and I think most of you come back with yes, you see it quite often. Uh, but one thing that we need to know is that if or provided that your cut edges are clean cut, provided you use the right tool, right method, right condition, the cut edges would not be needed for any further treatment. Okay. Most often we get this question of whether there should be any overpainting of the cut edges. The answer is no. Why? Because our most of the coating technology, like the galvanic coating technology, is able to provide what we call cut edge corrosion. That's why just now I mentioned earlier, if minor scratches or even the cut edges, if let's say it's done right, you should not see any sign of rusting spreading inward. Okay, so I think to answer your question, if let's say the cut edge is done right, no burrs, no burr edges, then there should not be any cleaning, and you should not consider that, because otherwise you are adding more cost or more effort to something that is not expected, right, to happen. And if let's say there's improper cutting tools or burr edges, then you should remove the burrs. If let's say you see any sign of rust, then remove the rust. If let's say you opt to cover it with certain type of protection systems, uh, uh, we have a technical bulletin on our website. You can actually look up, and we recommend not recommend we have a guideline on a certain type of paint to use to actually protect the cut edges if let's say it's too late for you to remove the burr. But another way I didn't mention earlier is that if let's say the cut edge rusted has already spread into a certain degree, maybe you should cut, basically like amputation now, you cut off the areas where it's already rusted. So to have a cleaner cut, basically a new beginning. So yeah, I hope that answer your question. So the next one will be regarding scratches. Do you reckon we no need to replace the sheets if unnoticeable from far? Yes. The answer is yes. We would reckon that you do not replace. I mean, actually, uh, that is very subjective to how the client will perceive it, because certain client would have more stringent requirements where the client themselves will go onto the roof and inspect the roof themselves. And of course, today's session I covered that, if let's say the scratch are not severe where you can't see from far, then my take is that you should not replace it. But certain client might not be so forgiving where they want it, no scratch at all. So one thing that you can discuss, I mean, again, I talk about being upfront with all parties. So if you see, I mean, your client cannot accept the scratches, then what are the recommendation that you can have is that you can recommend a few things: replacement, or paint over it, or maybe just leave it there, right? These three possibilities. But like I mentioned earlier, if let's say you leave it there, the possibility of it not propagating because there's still protection coating there is high, right? But if let's say client wanting you to over paint it, then you should actually prompt the client or be honest with the client that based on your knowledge, over painting will actually present a certain color difference to the surface. So whether they want to take it is up to them. So of course, if let's say client want you to replace it, then you can negotiate how to actually replace it, and what are the commercial agreement to that. So I won't get into that for this topic or for this session. So that is for you to discuss with your client. So I hope that answer your question. So my take, again, to summarize this, is that I wouldn't want anyone to spend more money if let's say I can't even see the scratches from far, and it doesn't even affect the integrity of the material. So moving on, next question. What's the recommendation to remove cement stains? Okay, so this is something that we are still exploring, cement stains. So actually, uh, based on our experience, we have not found a very proper or very convincing solution which can actually tell us that we can remove the cement stains once it's cured onto the surface properly without damaging the surface. So so far, we do not want to make any recommendation because we have not found those solutions yet. But feel free to hit us up or tell us if let's say you have found any solutions that are very conducive to remove cement stains. Then perhaps you can share it in the next session or in the future. But until then, I think the answer to that is we do not want to recommend any types of solution for cement stains. The best solution is always not have the problem in the first place, meaning to prevent cement stains. So the way to do so is have a proper communication line with all parties, meaning you should if let's say as a installer you really encounter those problems frequently, then you should actually inform the client or the party who actually controls the the following trade works, right? Then so that they can actually inform the other trade works to be more mindful of this cement stain. Of course, as a client or as a project managed developer or client or investor, if let's say you are aware that you encounter this problem very frequently, then perhaps you can actually use this chance or use this information that we shared today to actually inform your trade workers or your contractors. And I hope that answer your question. And I think if let's say there's no more question, then that's the end of today's session. And as usual, to end this, we would like to thank everyone who joined us today for our session of Steel Connect webinar. And of course, you can always access our website or even our YouTube channel for whatever content that we presented today. And for those architects who want to collect your LAM CPD points, upon ending of this session, you can there will be a pop-up link to the survey form where you can actually one of the section is you can fill in your LAM membership number. So we will actually apply for LAM CPD points for you. So if no further questions, then we will end today's session. And thanks again for joining this Steel Connect webinar.